Thank you for signing on to listen to this month's webinar, part 4 of the 2022 Plastek Academy series. As you continue to attend each month, you will hear presentations from non-Plastek organizations, specially designed that way to bring you value in these webinars, the same as we have received through our partnerships with these suppliers and through what they contribute to what we have built as the Plastek brand. The objective of the Plastek Group is to apply the most modern management techniques, quality disciplines, humane relations, and the latest in automation technology to ensure the continuous improvement of product, people, safety, and community. Hi, my name is Ray Kraus. As Director of Global Supply for the Plastek Group, one of my responsibilities is to oversee and advise business smart relationships and investments to gain access to and utilization of beneficial resources. Our goal is to continue to be a world-class manufacturer striving for the improvement of product, service competitiveness, customer satisfaction, and increased market share without sacrificing the integrity of our company, our fellow workers, or our customers. Plastek, utilizing the latest in automation technology, is an evolving and progressive part of our current and future operations. As one example of support to the goals committed to in the Plastek mission, we invited Muller Technologies to the Plastek Academy. Muller Technologies is a recognized leader providing automation support solutions to support the plastics industry. Thank you for attending this topic, flexible automation, increasing efficiencies, output, and speed to market.
Good morning, and thank you to Plastek for having us speak today. My name is Konowal. I am the Director of Sales and Marketing for Muller Technology. Tell you a little bit about the company. Muller Technology is a Swiss company. We have locations in the southern part of Switzerland, where we manufacture automation and injection molds. The molds are primarily for thin wall packaging applications. And we also have a facility in Fort Collins, Colorado, where I am based, where we produce automation, off-the-shelf types of automation for fast retrieval, custom automation that's downstream after we get the molded parts out of an injection molding machine or a thermoformer, and then also case packing and labor-saving type of automation, which is important at the moment. So today I'm going to talk to you about flexible automation, increasing efficiencies, output, and speed to market. The topics that I'm going to cover in this presentation are to define what rigid automation is, so that we're all on the same page. I'll go through what the differences are between fixed automation or rigid automation and flexible automation. I'll go through why fixed automation was the primary way that automation was built in the past and why, and also then the benefits of fast and efficient changeovers. I'll go through some examples of flexible automation and what goes into flexible automation. And then at the end, I'll show you applications, specific applications, real life applications of flexible automation. So the first one is, what is rigid automation? What's the definition of it? I have two pictures up here on the slide which show you rigid automation, not necessarily for plastics, but historical. And rigid automation is something that is designed and used for one specific task. So you see the counting machine on the left, and then the music making machine on the right. That's all they could do. They were not designed and could not perform anything than those specific functions. So what is rigid or fixed automation, and what are some of the reasons for it? So it's automation that's customized around a single molded product. The handling of it, the way it's transferred once it comes out of a molding machine, the nesting of the products, if there's some kind of assembly work that needs to be done, inspection work, everything is designed for one specific product. Very little flexibility. They're typically, the rigid and fixed automation was typically designed for a high volume, low mix type of production. So you produce that one part for years and years. It was designed to do high volume, so you could produce high cavitation. You could make a lot of those products all on the same system, but the system was designed specifically for that task. Changeovers were not possible or were very complicated. The picture on this slide shows what you needed to do to get it to work. It took duct tape, it took baling wires. You had to do a lot of rigging to make this fixed or rigid automation workable on other products or on different applications. And it took a lot of technical expertise. And as I listed in that slide, almost to the level of needing a PhD to figure out how to get it to work. So why was fixed automation used in the past? And when I say past, historically, the majority of automation was fixed. We've seen changes towards the more flexible automation in the last 3 to 5 years, with the biggest jump in changing over to flexible automation since COVID. And I'll go through some of the reasons that we see that that's happening. So why fixed automation? Why was it prevalent? Long product life cycles was a big driver. And I have some examples listed here. Televisions. In the past, you bought a television and you had it for 10 years, 15 years. There were very few variations in televisions until fairly recently. Now every year there's new resolution coming out, new TV sizes, new features, wireless features on televisions. That's just an example of what's happening in industry overall. The next one is mobile telephones. I remember the first phones that I had and most everyone had was a flip phone, and you kept that for years. And now every year Apple's coming out with the next one and the latest and greatest. Constant changes, so the product life cycles are becoming much shorter. Cassette tapes, same thing. Decades of cassette tapes, no changes. The molders that were running cassette tapes never had to change that automation because it was always the same size dimensionally. Nothing changed on it, so you just kept running it with the same automation. And the final one is the big brands with the food products. An example is Kraft Philadelphia cream cheese, and the other one is the Philadelphia mac and cheese. The mac and cheese has been out there for decades without a change, and now Kraft is looking at changing the name, changing the recipes, changing the packaging, which has an impact on how it's going to be molded. The next one is the high volume, low mix, produce the best bottom line results. A lot of this was driven by offshoring, which forced North American molders in particular, but even on a global basis, to focus on high volume production. A lot of the countries where labor was much lower were taking on the lower volume production. So to stay competitive and to be profitable, many molders had to go to high volume production. The next one is automation suppliers. So people like us, we are very reactive to the molder's needs. A molder would come to us and say, I have this product, I need to do this with it, and it has to end up here. And we would design a piece of automation that was very custom made, specific only for that product. We never gave any thought of what's going to happen when that product's life cycle ends. because life cycles were longer, that wasn't really a consideration that mattered. Now that has changed dramatically, where thinking about the flexibility and what can be done with a system in 2 years, in 3 years, in 5 years, that'll make it simple to change over and make it flexible. The next one is warehouse space. So warehouse space was plentiful, it was low cost. When I go to visit customers, I often go to a section of the warehouse that's kind of the graveyard. You'll see old automation stored, waiting, hoping that someday it could be repurposed for another application. But you go back year after year and it's still sitting there just collecting more and more dust because it's not flexible in any way, and to change it over is very complex. It stays in the warehouse until someone decides that they need that space and call a scrapyard and then junk it. So what are the benefits of fast and efficient changeover? The simplest answer to that is the picture on the right. It's financial. By having fast, efficient changeovers, it reduces costs and increases the bottom line and pushes towards the bottom of that picture, not $5 bills, but $50 bills, $100 bills, $1,000 bills. So that is the benefit that flexible automation offers. I used someone that everyone kind of correlates with being a wise man to put this quote out here, which comes from Supply Chain Management magazine. 50% of annual company revenues across a range of industries are derived from new products launched within the past 3 years. So this is from 2020. That is even getting tighter now, where it's not the past 3 years, it's the past 2 years. And this suggests that long-term product cash cows, which stay in a company's portfolio for many years, are becoming a thing of the past. So shorter product life cycles for a molder means there's going to be changes. You will not be able to run that same product for 10 years, 15 years as you did in the past. Contracts now are sometimes renewed every year and sent out for bidding every year. So in a year's time, that automation may be obsolete for that specific product, and it needs to be changed over to something new or put into that graveyard in the warehouse. So flexibility is critical. So flexibility and easy changeover. What does it mean? It means retasking on the fly. So regardless of the cavitation of the mold, whether it's a single face mold, stack mold, 4-level mold, regardless of the pitch of the mold, whether the product is cavity gated, corrugated, edge gated, the automation of the future and where flexibility is going is if the mold fits into the molding machine, the automation should easily adapt to that product. So whatever goes in the molding machine, as long as it fits between the tie bars, the automation needs to adapt to that. The next one is increased efficiency of the molding cell. A molding cell that's not running is only cost. So I often go into customers' plants and they have molding machines with a mold in them, with automation, but it's not running. Either because the production volume's already been filled for that month, or they're waiting for orders, but you have a very expensive molding machine, you have automation that is sitting there not being used. By having the versatility and the flexibility in the automation, you can reduce the costs because that's a fixed cost that's already set with the molding machine and the automation. You can increase your production volumes and you can improve the bottom line. The biggest fans of flexible automation are scheduling people, because if they have an empty molding machine, they know the flexible automation can handle it. and they can schedule whatever needs to be scheduled at that particular time into that molding machine. The next one is run small batches or large batch production. So dedicating a molding machine to only specific products, specific cycle times, or specific customer orders limits the molder's capabilities to take on additional jobs and additional customers. If you need to purchase another molding machine, another set of automation for a specific job, you cannot get to market quickly. Lead times currently are 30 to 40 weeks on capital equipment. So getting to market in under 30 or 40 weeks with new equipment sometimes just isn't viable, and it's not a competitive advantage, where the flexible automation allows you to get to market much quicker. And I'll go into lead times on the changes that need to be done on flexible automation further along in the presentation. Then quick automation changeovers. The other part is changing your automation over from one job to the other. And for us as a company, our target is for 30 minutes or less. What that does is it increases the capacity, the output, profits. The target for the 30 minutes is a couple different reasons drive that. One is mold changes. You want to have the automation changed out faster than you can do a mold change. And with a mold change, you typically have to heat up the mold, which takes some time. So 30 minutes lets the automation be changed over, and it's ready when the mold is ready for the next product changeover. Now I'm going to go into some examples of flexible automation. So I'm going to hit on some of the biggest ones that we've used and the applications. There's other ones out in the market that are being used. Some are a little more specific for different applications, so I kind of use the ones that are the most general and most wide used. It's important to pick the right automation for the application, and each of the four that I'm showing here, and I'll go into more depth on these and show examples, are specific to certain actions that the automation does. So the first one is takeout robots. What we supply is high-speed side entry robots that are very versatile and flexible and designed for maximum capabilities. So as I said before, whatever will go into the molding machine, this automation is easily adaptable to run that type of a product. One of the other items why this is a side entry and why we focus on side entry. In the past, we've built quite a bit of top entry automation. And what we're seeing in the market is a lot of people going away from top entry automation, primarily due to safety concerns. Not wanting employees to have to go up high in the air or need to have special safety harnessing or special safeties in place to use the top entry types of applications. So the side entry is something that we're seeing a lot of movement towards. The next one is SCARA robots. The SCARA robots are very quick. They're designed primarily for lighter duty applications. Typically for us and for most people that are using these, they're for pick and place applications. They're very good for single part handling, and they handle high rates. A typical SCARA can handle with a single end of arm tool, meaning it can pick up one part at a time, about 90 parts per minute. And if you put an end of arm tool on there that can handle 2 parts or 4 parts, you double or quadruple the number of parts that you can handle per minute going past it. The next one I'm going to touch on is a 6-axis robot. So 6-axis robots have been out there for quite a while, heavily used in the automotive industry to automate and for labor savings. We're seeing a lot of movement and new entry of 6-axis robots in the plastics industry. These are articulating arm robots, offer great flexibility, basically work just like a human arm with a wrist on it and can do the same kind of motion. They offer substantial reach. They can handle large payloads. They aren't the fastest, so there are some limitations on cycle time with 6-axis robots. The next one is cobots. So cobots are something that have become much more popular, say over the last, again, 3 to 5 years. A cobot is a collaborative robot which allows interaction with a safe human-machine. It's safe human-machine interaction. Applicable for handling, assembly, transfer applications. What the cobot does is it has safeties built into it that when a human, an operator, a packer, an employee walks near it into a certain range area that's settable, the robot will slow down and go to a safe speed so that if there is contact with the person, it won't cause them harm. The benefit of the cobots is you don't have to have any kind of physical guarding around them. It's all done with sensors, so you don't have to have fencing or metal guarding around them. Very versatile, easy to move around from application to application. A lot of different sizes, ranges, speeds, so a lot of versatility. I'm sure we're going to see more and more cobot applications in the plastics industry as they develop and new applications are tried. So now I'm going to show you some examples of actual applications. So the first one is the side entry takeout robot.
Hello, I'm John Taggart, Vice President of Engineering, Muller Technology, Colorado. This is the online robot. It was a joint development between Muller Technology, Colorado and Muller Technology, Switzerland, with the goal of developing a platform that could be rolled out worldwide. Our goal in designing this side entry inline robot was to make one robot that's capable of running with.
Oops, sorry about that. Technical difficulty.
Hello, I'm John Taggart, Vice President of Engineering at Muller Technology, Colorado. This is the online robot. It was a joint development between Muller Technology, Colorado and Muller Technology, Switzerland, with the goal of developing a platform that could be rolled out worldwide. Our goal in designing this side entry inline robot was to make one robot that's capable of running with any mold you put into a molding machine, whether that's stack mold, single face mold, whether it's inside gated, outside gated. This robot can handle any of those mold configurations. The robot is capable of stacking up to any number of parts that you want. That's recipe selectable, change it, push the button. The robot has incredible flexibility with 4 axes on each arm, all motor controlled. Rather than multiple handoffs, we're capturing the part with one tool and placing it directly on the conveyor. For this new arm design, we've spent extensive time working at FDA to make sure that we get stiff, stable arms that eliminates shakes. In addition to that, our tooling changeover has been greatly simplified. We're down to 6 bolts, air quick disconnects on the back, the entire tool comes off, then you can bring a new tool in. Tooling's lightweight, one person can hold it up, dowel pin to align it, put it in place, put your 6 bolts back in, hook your air in, and you're ready to run. We can accommodate anywhere from 1 cavity up to 48 cavities. Very flexible, very lightweight, very fast, very rigid. Our end-of-arm retrieval carriage has the capability to rotate a full 180 degrees, and this is what allows us to pick either face of the mold with either arm. So that is recipe selectable at the HMI. You just tell it which mold face you want to pick off of, and it will home accordingly, pick off that face, move forward. For each of our arms, we have independent servo control in the strip stroke direction or the clamp direction of the mold. There's a motor that drives the belt and gives us full control over where that arm is when it's moving in and out of the system. Once we are in position, we're always verifying with the linear transducer that we are in position so that we're sure that we're clear to go in the mold. In addition to that, if your mold center line height changes, we have a separate bolt pattern here that we can move our entire traverse beam up and down to adjust the center line of your mold.
This is another application that I'm showing. This is actually running in our shop. Our customer will not let me show you the actual product. This is for a 2-piece closure that's molded in a family mold. So we actually take out both products at the same time and then use the automation to assemble the one piece to the base of the closure. You can see the cavitation. This is the same exact robot that was shown in the previous video. Absolutely no different in the base setup of it. The only difference is in the end of arm tooling. The critical part with these takeout robots is the flexibility and versatility. So you can run 2 arms if it's a stack mold. If it's a single face mold, you turn off 1 arm and the second one keeps running. We've built these up to 4-level molds where our customers are running single face, stack molds, and 4-level molds all on the same automation. And what we're finding from the industry is that our customers that have this type of automation are seeing utilization rates above 90% because they can put whatever mold that they have that needs production at that time into the machine, and the automation will adapt quickly and easily and run it. The next one I'm going to show is the SCARA. This is the pick and place application. Here I'm showing it for lids. The SCARAs that we use, we always use in conjunction with a vision system. So you can see the flashing at the far end of this video. The vision system takes a quick picture of each part, and as you can see, some of them are not oriented in the same direction, and you'll see one coming up that's quite skewed. The vision system sends a signal to the SCARA rotates and puts it into position so that you can put it into a stacker, or if you're doing some assembly type of work, the correlation or the co-work between the vision system and the SCARA lets it do that alignment adjustment on the fly. And again, as I mentioned, with high speed capabilities of 90, 180 parts per minute. The next one is the 6-axis robot. The 6-axis robot has a lot of versatility, and in this video, I'm going to show a number of different applications. The important thing to notice and realize on this is the 6-axis is all the same, but the applications are very different, and it just shows the flexibility that's possible with the 6-axis. So here, takeout. This is a hinged closure or hinged top. Pure takeout, placing it into a fixture, which will then go on and close that hinged top. So fairly simple application, just going in with a strip stroke using vacuum or using grippers to grab the part out of the molding machine. Same type of robot here for palletizing. Placing a slip sheet for the next layer, then going onto the conveyor that's feeding the parts, picking up a row of parts in the orientation for palletizing, moving over and building the layer. And the only real difference between what you saw in the takeout and this palletizing is the end of arm tooling and then the programming. But very much flexible for different applications. This one is for an IML, in-mold labeling application. So the 6-axis robot is taking labels from a label magazine, placing them into the mold cavity, taking out the finished product, and stacking the finished product when it is complete. Again, only change out is in the end of arm tooling. Another application for a 6-axis. In this case, we're using a vacuum head, picking stacks of containers and case packing them. These case packers that we build are designed for different orientations in the box, different cavitations. You can see these trays. You can slide the trays together, move them closer, further apart. For the 6-axis robot, it's all positioning in the programming. You can pick as many different trays worth, different heights. All of that is a simple change out in the end of arm tooling. The next one is a blow molded container. So here you can see the blow molded containers being single file sent into the system. We build a row, build an array, and then the 6-axis robot picks them up with a vacuum head and places them into the box. For different box orientations, different number of these bottles in the box. The only change out, again, is the end of arm tooling and programming. So if this particular job went through its life cycle, was no longer something that was being produced and molded, this 6-axis robot could be easily converted over to the IML application, to a takeout application, to any of those different, the case packing of container application with a very simple change out. The next one I'm going to show is the cobots. I've included something on this graphic, which I'm not going to touch on in this presentation. Maybe it will be something for the future, but it's something that we're seeing quite a bit of in plastics. The bottom of this unit, which the cobot is sitting on. This is an AMR, which is an automated mobile robot. These we're seeing more and more in plants for labor savings, cleanliness, and what they're being used for. This picture on top is showing this is actually a clean room molding application for a medical product in Europe. And these AMRs are transporting finished boxes. They're bringing empty boxes to the filling, which is coming off of an injection molding machine. And they're using cobots mounted to the top of these AMRs that are going through the plant. These are fully autonomous. There's no guiding in the floor, no wiring, all based on sensors and GPS signaling. Enterprise program that sends them to where they're needed. When a molding machine has finished products and is ready for boxes to be picked up, it signals an AMR. The enterprise software will send the closest AMR to that location, pick up the box and bring it to a central palletizing area, a QC area, whatever needs to be done with that product. And now I'll show you some cobot applications. So these cobots that we supply are mounted on a self-standing unit, which has all of the power, it has the air, it even has the HMI built into the unit. This unit is either on casters or could be moved with a pallet jack. The cobot here that you see is using a mechanical gripper. You can use a mechanical gripper, you can use a pneumatic gripper, you can use vacuum, whatever is needed for the specific application. And you can see it now moving in a slower motion. That is the collaborative motion, which is a safe motion so that if an employee comes near it, there is no chance for injury. This is for another application showing it using a vacuum head. Here at the bottom, you can see a scanner. This is the space scanner. Once a person enters the area within 6 feet of that scanner, the robot goes into a collaborative slow mode. And then you saw the operator hit a button on top, which indicates he's leaving the area, and the cobot can move back to a fast movement. Here again, using a vacuum head with a high flow vacuum, picking lids off of spin bars and case packing them. Again, very versatile. The only difference between all these applications is again in the head. It's in the end of arm tooling. The rest is all standard. It can be moved from application to application. Fast changeouts, where you're just changing the end of arm tooling, you're looking at, like I said, 5 minutes to a half hour at most to change the automation from one application to another. So to summarize, what does flexible automation do? One of the biggest things is higher utilization. The molding cells are not limited to one product. Scheduling becomes very open, very easy to schedule things based on molding machine availability and not specific product availability. You can retask on the fly, changing over from 5 minutes to a half hour. It increases competitiveness because you're able to produce on more molding machines. You can change faster. You can deliver to the end customer the products faster. Faster to market. As I showed you, the only thing that's changing out on all of this automation is the end of arm tooling. You can enter a new market in 10 to 12 weeks at most. That's the lead time that it takes to design and produce new end of arm tooling. So if a customer has a product that they want to get to market in 12 weeks, 10 weeks, sometimes even less, highly flexible automation lets you get to market much sooner than you would with something like I mentioned, with lead times that you're looking at 30 to 40 weeks just for the equipment to come in and then to set it up. So it reduces fourfold the time to enter a new market. Quick changeovers, 10 to 30 minutes. Limited technical expertise, as that takeout video showed. When you design a system to be flexible, in that case, 6 bolts that need to be changed out and a vacuum connection. That's it. You don't need highly technical people that have to make adjustments, fine tune it. It's all done in the design and simple to change over. And reduces the downtime between switching from product to product. You're not taking 8 hours a shift or days to change over automation to something from one product to the next. That concludes my presentation. Thank you for your attention. And I think Nicole is going to take over from here.
Thanks to Ross for that handover and great presentation with the detailed summary. There's a lot of information there, and I want to thank you for taking the time to share that with us and our audience that we have on today. So we want to take a turn here in our traditional webinars, Season 2, Series 2 at the Plastek Academy, and turn it over to our audience that we have on today. I do see a small group here with a variety of roles that they play in the plastics industry. So from marketing to procurement to project managers to sales, engineers. So great group, and hopefully we get some great questions. So as we give Taras a minute here, I want to encourage everyone to recall what was discussed today and start submitting your questions that we can answer live for you here. If you haven't joined us on a Plastek Academy webinar and go to webinar dashboard, you see that there. You can open it up and submit your questions using text and your keyboard. They will be anonymous to us here as the presenters, and we'll see what more information we can uncover in this session today.
While people are thinking of questions, one thing I wanted to mention is that specifically on Plastek, so Plastek has invested in those takeout robots for applications where the cavitation changes and the mold pitch changes. So they can run the ones that we're working on, they can run anywhere from 2 to 4 different products on that one automation system. So it'll go into one molding machine, which has a, I believe it's a 600-ton machine, and 4 different products can be run all on it, the same automation, and all that the change out is the end of arm tooling that matches the cavitation and the specific mold pitch.
All right, we do have a couple questions coming in here, and I want to get started with a question surrounding the interest of cost. So we heard in your explanations today many benefits of it, from labor savings to safety to quality control and all of that, and the speed to market aspect of it. So many positive things there. So in the long run, how is the cost comparison looked at from flexible automation to fixed automation?
So typically, the more flexible it is, the more cost is involved with it. It depends on, so companies like us, a lot of us are heading towards flexible automation based on standard products. So a lot of the features are designed in with the thought of the flexibility. But if it was, let's say, one-on-one, you'll probably see a cost difference of maybe 10 to 20% higher for the flexible automation. For the base automation, the biggest differences are then the end of arm tooling. When you're buying additional end of arm tooling, there's additional costs on top of that 10 to 20%. I hope that answers the question.
Yeah. And again, with a large group and different roles coming in, we're always going to see those different individual scenarios across and through the plastics industry, but overall looking to target the key topics that we all face in our daily operations. So, well, before we go to the next question, I also just want to let you guys know and remind yourselves, as what you can see on the screen, any individual specific questions that you have to make inquiries back to Taras at Muller and his team. We do have the contact information shared with you here on screen, so make a note of that before you leave today. And with that, going into the next question, again, I myself am a human resources background, and here pairing that with marketing. So I get to engage with a lot of different departments within organizations. And one of the key things that I found, of course, as a benefit is the safety, the quality control, the cleanliness, again, the labor savings and all of that. But for our viewers who may be in the procurement, the process managers, the project managers, or even the individuals who place the bids or request bids, create the estimates for the projects, what impact does molding cycle time have on choosing an appropriate automation application?
Good question. So the cycle time has an impact on a couple different things. One is the type of automation that you're going to use. So 6-axis robots are phenomenal. Their flexibility is almost unlimited. They have huge advantages of very low maintenance. Typically, their first PM is after 3 years. They're pretty much bulletproof. That they're very good in terms of downtime and what's needed from a maintenance standpoint. So that impacts the cost overall of running over the life of the system. The other part is they aren't fast. They can be fast, but most of them are not designed to run, let's say, sub 5-second cycle or sub 7-second cycles. They're usually used for a slower application. So when costing and using 6-axis robots, they do have limitations. As an example, our takeout robots, we've designed those for a 4-second cycle as a standard, as a base. So If you're running anything above that, it can easily handle it. Cobots are probably the third tier there. Because they can go into a collaborative mode, they slow down to about 50% of the speed. So the cycle time, it's not going to move like a 6-axis that's fully guarded. It's going to move slower, so you have to be very cautious on cycle time. There are some bigger limitations on the cobot. So kind of as a sequence, the takeout robots, very little limitation on cycle time. 6-axis robots, you're limited somewhat in the cycle time, and then the cobots are the ones that you have to be the most careful with in terms of speccing them out and costing them into a project, because you don't know how often people are going to walk into the range of their area. You can have 2 people come in Monday morning and talk about what they did on the weekend, and the cobot's moving at half its speed, which may not keep up with the normal cycle time.
Very good. All right, looking at our time here, we're going to get one more question in, or category of question in, for you to summarize for us today, Taras, if you would, and then followed by any closing statements. Again, benefits, cost, but the main thing is we all want to make our customers happy and keep our employees safe and have put out good quality products. So looking at it full picture, as we determine what application is best, what vendor, supplier is best. We have our expert on with us today, as Plastek does work with Muller. But can you just summarize what make of access robots or cobot robots do you use and why?
Yes. So for the 6-axis robots, we use the Stably robots. The reason we use Stably, we tested pretty much every 6-axis robot on the market. The reason we chose Stably, there are multiple reasons. One was speed. They are on the higher end of speeds, and a lot of what the applications we do are high speed. We're sub 10-second cycles for the majority of our applications. They were very good at the speed. The others you could probably have seen in the videos and some of the graphics that I had, very clean. All of their utilities, so the vacuum lines, the electric lines, all are run on the inside of the arm. They're clean, and you don't have hoses or electric lines flopping around. And the other is the capability of programming. We integrate the Stably robot into our standard HMI so that it's very simple for the operators. What we're seeing in the market is technical skill, technical labor is in short supply. So the simpler it is to program, the simpler it is to change over, the more important that's becoming. And we found Stably to have the most versatility and ease of use. For the cobots, we are using Omron, and that's a TM cobot. And the reason we use that one specifically is it has vision integrated into the robot arm. And with the vision, we can do inspection, we can do more accurate position location and confirm it with the vision, and having it integrated into the arm and into the software makes that the most versatile. So that was the reason, the main reason we used it. The other is there's a lot of cobots out on the market. There's a lot of them that have weaknesses in their joints, where the joints will wear out quickly. And because again, we're running a lot of quicker cycle times, quicker movements, the joint life was extremely important for us, and we found that the Omron joint life is longer than most of the other cobots out on the market.
Very good. Well, I think that we can all definitely leave here today with a piece of information that we may not have been familiar with before. So again, thank you, Taras, for sharing your knowledge with us today. Everyone, as we move through the end of the webinar, I just again want to thank you for joining us. This is our last slide to share with you. Again, return viewer of the Plastek Academy, first time viewer of the Plastek Academy. If you see something here that you liked and wanted to share with your team or colleagues, any students, This will be available on demand for replay once we have processed that and uploaded it to our plastekgroup.com/plastek-academy website or the GoToWebinar platform. So it will be shareable. If you need to take some more notes, you can watch this back again. Any contact information, please take that down now for either the Plastek Group or Muller. And then also look forward to joining us in our next month webinar presented by Penn State Barron on mechatronics. And then the remainder of our series listed there for you on the right with our expert presenters. You will be prompted with a brief survey if you wouldn't mind taking a moment to do that for us as you exit the webinar today. And until next month, have a great day. Thank you.
Thank you, Nicole.